Resume recording. My printer is going to kick in just a second here, but class 12, we have some agenda tonight. We're going to go over some old homework problems, some things that I'm seeing as the homeworks come in and as I go through and grade them, some consistent errors. We're going to go back over horizontal and vertical curves, earthwork and volumes. I have that we're going to use scales, but that's kind of all part and parcel of the whole thing. Reviewing topography, topo maps, and elevations. Then we have exam 3 coming up. So not necessarily in this order. Exam 3 is down at the end, but we are going to just kind of jump right in, start talking about everything that we've been covering lately. If you have questions at any point in time, go ahead and ask. We'll probably get to them at some point. Pretty much just going to be walking through a bunch of problems. What I just printed out is, I don't know does anybody have Joanne for classes this semester? Give me a thumbs up if you do. No one's got Joanne? Oh, Marcy, okay. What Joanne has been doing is Miles, okay. She printed out everybody's names and she has been calling on people throughout the semester. Up until today, I've just relied on input from you guys, but this point in the semester, I really need to kind of start getting a gauge on where you stand. Your interaction with me tonight is really going to give me a lot of information because I have some decisions to make. So Olga, you made it. Oh, that's wonderful. I'm so glad everything worked out.
It was hard. Thank you.
Understandable. One other thing. So I'm going to be calling on people as we go around. I'm going to try and do it in reverse alphabet order. That means Viri, Victoria, you guys are coming up first. You're probably going to be the first ones up. Go ahead and pass. If you're really stumped, it is okay to pass. I'll just roll to the next person, but I will circle back to you at another point in time this evening. I did not plan out exactly so many questions, but definitely want to get the feedback and the connection with you guys. Tonight, I see Kenny and Othello have their cameras on. It would also really help me tonight in particular if you had your cameras on. I can see if your eyes are rolling back in your head and you're falling asleep. If you're just so totally lost, you're pulling your hair out, things like that. Really are going to give me some clues because like I said, I got some stuff I gotta figure out, and your input is critical in that decision. So comments from past homework assignments. Thank you, John. This is one of those that just about everybody struggled with. It was confusing. So one thing I really want to point out and really stress is read the questions carefully. Miles, I think it was, I was talking to you and I said, in preparing the exam, I was reading through one of the questions and I could not understand it myself. I struggled. And it took a while to reinterpret what the words were actually asking. Once I understood that and I was overthinking it, I do that a lot, everything was good. All of a sudden it clicked, light bulb moment, everything made sense. So if you don't understand what the question is asking, if you don't understand where it's coming from, ask the question. Send me a message in chat. We can then post it to everybody else. But if you're struggling with it, then others are probably struggling with it and overthinking it and getting frustrated. So let's just all kind of take care of each other and not get to that point. This one was tough. So homework number 8, when we did topography, question 3 stated that on a map sheet having a scale of 1 to 4,800, what is the smallest distance that can be plotted with an engineer's scale? The minimum scale gradation is 1 to 60, 1/60th of an inch. So down here, this is what we're talking about. That's what we're looking at. If we were to look at the 1 to 10 scale, right, there are 10 divisions within that 1 inch mark. If we look at this 60 scale, there's a lot more in there. It's divided up pretty small. So if we have a ratio of 1 to 4,800, those ratios are unitless. If there is no unit, it's unitless. It's just a 1-to-1, right? So it could be inches to inches, feet to feet, miles to miles. So starting at the bottom of our list, reverse alphabetical order, as somebody with the first name Sarah, last name Urbic, I was always at the end of the alphabet. So lining up, I was always last to go to recess. I hated that. I was hoping to get married to somebody with the last name of A, but that didn't work out either. All right, so starting with Viri, if you would, please. Again, you're free to pass if you need to, but for a ratio of 1 to 4,800, what is the equivalent engineering scale?
I'm a little bit confused on that one. So
Okay.
I would say that we could do.
I would go back to the lecture notes.
Okay.
So what just popped up on the screen is a screenshot of a handy conversion chart.
So would that be the 0.001389?
0.01389. No, we're talking about 1 to 4,800. So since we're dealing with a ratio.
So it would be the 1 inch to 400 feet.
Yes, absolutely. That's correct. Okay.
Cool.
So that's what we're looking for here, is get it into some units that we can figure out. If we're dealing with an engineer's scale, we're usually dealing with inches to feet, right? That's pretty standard for civil engineers. So if we're looking at this 0.6 mark, let's see where this is 6. 6 would be right in here. Oops, there you go. So how many tick marks are there from that 0 to that 6 mark on this scale? We're going to come up to Victoria.
From 0 to 6, how many tick marks?
Yeah, from 0 to 6. How many of these little tick marks are there?
How many is there between? I don't know. I have no idea.
Okay.
Honestly.
So it's broken up on the 60 scale. What it's saying is that for every inch, there's 60 tick marks. So that's what it's looking for there. That's what we wanted to ferret out on this particular question, okay? So from 0 to 6, there's 60 of those little individual tick marks. And Kenny, I know you've got the eyesight of a hawk, but we're just going to stick with the tick marks. It's not like reading. It's not like reading the rod when we're out in the field, right? Where you can interpolate between. We're sticking pretty close to, especially down to those 60ths. And I'm zoomed way in on that image, and it's still really hard to see. It's hard to get a good image of these scales. If you don't have one yet, you're gonna need one, okay? We've gotten by this semester without it, but by the time you get to statics, graphics, any of the other classes, you're gonna you're going to start living with this thing. So from 0 to 6 on the 60 scale, there's 60 little increments. So that means we can measure one, let's see, let me make sure I'm on the right one. Yep. 1/60th from this 0 right here to that very first little tick mark. That is 1/60th of an inch. Okay. So from 0 to 6, that is 1 inch on our scale. So if that's divided into 60 little pieces, we have 1/60th is our smallest amount that we can measure. Okay. So if the equivalent scale, we can say we've got 1 inch is 400 on our piece of paper. But the smallest we can measure is 1/60th of an inch. So how does that correlate? What does that measure out? If I take these segments and I measure out 400 feet, how long is it from this 0 over to this little tiny teeny tick mark? And that brings us to Othello. Yes, Lucy, we see you. You're muted.
Feet. Oh, okay. Thank you. All right. Let's see. Tick marks. What does one tick mark represent? Okay. Would that be like 6 to the? Is it okay if I just say decimal for it?
Yeah.
Okay, so what I ended up doing was I said, okay, 1 inch equals 400 feet, and I ended up dividing that by 60 tick marks, 400 by 60, and I got 6.667 for each tick mark.
That's exactly correct. That's what we're looking for, is that if this whole distance, regardless of whatever numbers are down below here, this whole distance is 400 feet, we're saying. So how far is it from here to here? What portion of that?
Right.
So that's the math we're looking for on that. All right. So I got some varied answers on that. Some of the work shown didn't quite show the thought process. So I wanted to go over that and make sure we were all kind of on the same page. One thing that I forgot to do, I meant to do this earlier, is one of the questions that we talked about was homework 7, question 4, right? And it was if we have a room, an architect drew a room that is a scale of 1 to 1600. But we go out and we measure one length of that on our plan and we come up with a certain length. So I was struggling to explain how it comes about that it really is a fourth. It's a quarter of what we're looking at. It's a square root because we're dealing with squares. So what I want to do is bring this over. Kenny, do you want to present? I like the mask. It's a lot of team spirit there. So I'll read the problem while you're getting set up. An architect creates a blueprint of a rectangular dining room. The area of the room is 1,600 times larger than the area of the dining room on the blueprint. Length of the room on the blueprint measures 3 inches. What is the length of the actual dining room in feet? So Kenny drew this out, plotted it out, and came up with a much better explanation than my stumbling. So I'd like to turn it over.
Okay.
Are you muted?
Can you hear
there
me
we
now?
go. Yeah.
Okay. Yeah, I was muted. I was sharing a room, so and there's like another thing going on in there. So Um, yeah, so
Sorry to put you on the spot then.
no problem. Hang on a second. Let me just stick the ear. Okay, so what I did at first, when I first read the problem, I saw architect scale, inches, quarter inches, half inch, 1/16, 132, 164. I was thinking it was something like 128 inches to the foot. Then I was thankful that it's an engineering class. So I got my engineering scale out and went, okay, can't be that bad. What I thought was it's an area problem. So the first problem is to find out what the scale is. And since it's an area problem, we don't know what the dimensions are, but it says that for every bit, it's 1,600 times bigger. So since you have to stretch both width and length, I went ahead and thought, okay, whatever I multiply it by has to be the same in both directions. And it's going to be a big number. And so in my brain, this little square came out, and I just printed it out so it's a visual there with the different scales. If you have a 1 to 10 scale, you actually have 100 increments. It's kind of like how many inches are in a square foot. You got 12 inches by 12 inches, you have 144 square inches in a square foot. And so I just multiplied it out and went, okay, then if we take the 1,600, I know there's 100 and there's a 16. So that's 4 and then a 10. So it's 40. So with a scale of 1 to 40, if 1 inch is equal to 40 inches, how big is 3 inches? Well, 3 times 40 is 120 inches, and 120 inches is 10 feet. So getting over that first hurdle of, wow, 1,600 is a big number. How am I going to deal with this? And what's the scale? Once you get that done, the rest of the problem was pretty straightforward.
Thank you very much. And it's the graphic that really drove it home for me was like, oh my God, yes, that's it. Showing the proportions, how when you expand in one direction, you have to expand in the other. And since it's equal expansion, then we can reduce it equally as well.
Yeah, and I think you had the right instinct of this. Go, well, what's the square root of it? But then why are you using the square root? This shows it because you're multiplying both directions at the same time. So
thank you very much.
Yeah, thank you.
You put into graphics and into words what I was struggling to do.
Oh, and you're welcome to post the files if anybody wants to read over it. So that's fine with me.
Yeah, I think so. Othello, what's up?
Okay.
Oh, and in the chat, Mason also said they did a different way. Sorry, Mason, if I'm putting you on the spot, but that'd be interesting to hear.
Yeah, Mason.
Yeah, that was kind of, I don't know. I just read it as 1,600 times the size, or that area of the bigger room is 1,600 times larger than the area of the smaller room.
Mm-hmm.
And since we knew that the area of the small room was, or the length is 3 inches, I just assumed it was a square, like Kenny. So 3 by 3. So the area would be 9 inches squared. So I just did 9 times 1,600 and then got 14,400 squared inches. Then just make that into just normal inches, so 120, and then 10 feet from that. So I don't know.
One thing to watch out for there is how you went from square inches to inches.
You just
So the math worked out, but this actually does lead into something I'm going to kind of harp on a lot in a little bit, and it's units of measure. So again, you're correct, but just how did you get from an area measurement to a linear measurement?
I just did the square root of 14,400.
So because you assumed a square structure, and so that was a lucky break, we'll say.
I was not going to assume that it was a square because it said length. And so but I didn't know what the dimensions were, just that whatever the dimensions are, the whole thing is going to be 1,600 times bigger. So
Yeah. All right.
but thinking
so
of it as
does
a square
that,
does help.
oh, squares are easy. Squares are great. Everything should be squares. Length times width. Square the length. So Kenny, thank you for that. Mason, thank you for sharing your approach. I didn't pull it up, but I did post the answers and I did a ratio as well. And Mason, I basically made the same assumption. You know, it was, well, I don't know why this works. It just does. So I liked the visual that Kenny sent and I appreciate that. Thank you. All right. So I can hide that. Drawing contours. How many of you absolutely loved this and how many of you wanted to throw the paper across the room? Which, you know, unless you crumple it up and weigh it down with something, it doesn't do a whole hell of a lot.
No comment.
So there's a reason I picked these specific problems to go over. This was one of the homework assignments, right? It was out of the back of the book and it said they were 50 by 50 squares and it gave the coordinates, it gave the elevations at each one of those points in kind of a table format. So what I did was I blew it up and put it to scale, basically. So over the course of this 50 feet here, our elevation changes by 3.4 feet, right? Same thing with all the rest of those locations. And so what we want to do, the way to tackle this, probably the most conveniently, is to pick what's our highest point? What's our range? What are we dealing with? Highest point, 84.6. Our lowest point, we're down here at 58.5. Okay, so we know kind of the range that we need to be in. To simplify what we're going to do here, instead of doing every foot or every 2 feet like we did on the homework, I'm going to do every 5 feet because we could be here for hours getting nitpicky, scaling off each one of those lines and figuring out how far to go to hit that whole number mark, to hit that contour line, right? One thing also to watch out for is lines need to be pretty smooth. Even if you need to sketch it in, if you start seeing zigzags or hard angles, then something's going on with the terrain right there. Something's happening that the elevation isn't just kind of cruising along, it's jumping. So hard angles, straight lines, things to watch out for, right? Regular everyday contours, if you were to look at a hillside, they're nice, kind of easy rolling, pretty much, unless you're looking at a cliff. Then they're all stacked on top of each other. But for this case, what we're going to do is every 5 feet. So I figured up that between 58 and 84, we're going to have the contours for 60, 65, 70, 75, and 80. We are skipping the major and minor contours discussion. But what we need to remember, and I saw this a bunch, the only difference between those two is to highlight those big increments, right? So we can count 1, 2, 3, 4, 5, and that's a big benchmark, right? That's a nice even number. We go another 5 and we highlight the 10, so on and so forth. And so it draws your eye to the major formations. Then we get down a little deeper and start looking at what's happening on the individual level. Every foot, every 5 feet, every 10 feet, depending on what our contour spacing is. The major contours give us the big picture. The minor contours give us the details. Okay. And it's just to help you focus in and find what elevation am I looking at? Because otherwise it's just a bunch of squiggles. very rarely do you get this format handed to you, right? Well, no, as an engineer, you would see this probably a lot more than I would as in construction. Usually an engineer's already gone through and made this pretty. So if we start out, let's pick that first contour line, points for 60. I'm trying to remember how I grouped all this stuff together so that every time I hit the tab button, what's going to pop up. So if I'm looking at where would all of my 60 foot elevations be? Somewhere between 58.5 and 62.8. How far between? What's the difference between those two, and where would my elevation of 60 be likely to fall? If we're doing this by hand, if this is what we're given, rough is fine. It doesn't have to be exact. We don't have to measure it out. Olga, do you want to jump in real quick and kind of tell me where one of those points for 60 would be?
Okay, let's see. We have 0.5 until 60 from the right and 0.8 feet from, no. Oh, we have a lot. Okay, so we have 60, 61, 62. We actually have 3 lines running somewhere here. So approximately the 60 would be closer to 58.5 than to everything else. And it's going to be maybe like 1/5 of the distance of the whole line.
Well, let me hit my space bar and see where I plotted those. But that makes absolute sense, right? So in order to get to 60, I would have to add, my thought process is I add 1.5. To get from 60 to my next line, I have to add 2.8. Well, 1.5 is almost half. So that puts me down here in this 2/3 kind of area. Right about where Olga told me to put the X, okay? I repeated the process with these other 2 places where it's gonna cross. I know I missed a few of them when I went through and did this afternoon. And it's not the end of the world if you miss 1 or 2. It is the end of the world if you miss major features. How do you know if you miss major features? You have to know what you expect to get, and then you have to realize that it's not there. Okay. So I think my next one was my 80s. Or not my 80s. Did I do 80? Yeah. Hang on one second. Let me make sure. I don't want to ruin the surprise. All right. Hide that for a minute. All right. So let's look at the 80s. Who's up next? I have Miles on my list. Miles, can you tell me, pick one of those points and tell me where the 80 would fall along those lines?
We could do between the 78.7 and 80.7.
Okay.
So we're about 1.3 from the 78.7. So 1.3 divided by the difference of that, which would be 2. It's like whatever that is. Let's see.
So it's a nice even number. We've got exactly 2 feet difference stretched over that 50-foot mark, right? Notice that that distance really doesn't come into play at all. We're just eyeballing it. It doesn't matter if it's 50 feet, 100 feet, 200 feet. right? We're just catching those elevations in order to do the topo map. So would you say it's halfway, 3/4 of the way, 1/4 of the way,
55% of the way there.
55%?
Precisely, yeah.
Oh, sorry. I should have had you do 75.
Oh,
My bad, I misinterpreted. All right. So 75 is nice and easy. We'll just jump back a little bit. I have an exact corner that's given at 75.0. Going through, I can mark my X's somewhere between 74 and 76.1. That's pretty damn close to halfway, right? That's nice and easy. Oops, I missed I missed an X in here, right? So where I cross 75, somewhere between this 70 and this 76 would be back about here, but I forgot to put that X in. Is that going to make a big difference? Think about it for a little bit, okay? Mason, I'll come to you when we're ready for an answer on that one. All right, did the same thing with my 65 points. I put those in blue so we could see where they were, where they fall crossing those lines. All right, 70. There's my 80. I knew it would come in soon. All right. Now that we've done that, color coded it, looks great, kind of, sort of. Now what we want to do is we want to use nice, smooth lines, sketch it in, get it in there. And I know you guys just absolutely die every time I use my mouse to draw a line. You are going to be so proud of me. Look at that nice, smooth curve hitting all three of those points. Since you guys are smiling and nodding. Yeah, see, I finally figured it out. All right. So what we can do is we can come through, draw a line to hit all those different points. Now with the blue line, we can see that we're going to go a little to the right, and then we're going to come back to the left on our way down. Okay. The black lines, the black X's, something's going on there. Well, based on the way it's doing that, kind of that S curve, and the way the blue line's doing a little something different, maybe I am in trouble if I missed that point. Okay. So I'm going to keep hitting the space bar, and we're going to follow through. We're going to draw the black line. It gives us a little whoop-de-doo. Okay. Mason, what do you think is going to happen on that green line? I'll give you a hint. This time I caught my mistake before I graphed it. But if I didn't, what was going to happen?
Wouldn't it just pretty much intersect with the one of the black marks? Or is
Very,
it just
very
straight?
close.
It's just straight.
It would just be a straight line between those 2 points, right?
Yeah. So
No
would that mean
up,
you
no
missed a point then, maybe?
Right here, yes.
Oh, since it's
So,
75. Yeah.
If this is basically 70 and this is basically 76, then I need to be 4/5 of the way across, right?
Yeah.
No. 2/3.
Yeah.
So we'll go ahead and hit the space bar. So I went and caught it. So I did go through that point instead of making it a straight line. But that's something we've got to watch out for, because that would have given me a slightly different contour, right? I would have had a much steeper gradient here than I do, because my 70 contour line would have been closer to my 75 contour line. And Marcine, I have you on my list. Did you want to answer a question?
I'm sure. What's the question?
So this one's kind of a softball. So if I had completely missed that point and I had a straight line from this X down here, what would that do to the distance here? And what would that mean? How would I interpret that?
The distance between the green line and the black line would be much smaller, so that would tell you it's a lot steeper than it actually is. And there's also a point between 69.6 and 76.6. You'd also have to find another, although the next point is like really close by, there's another
Oh,
point you would mark in there.
yeah, there's a 70 and a 75 in there that I missed. Good catch. Okay, I'm not calling on you anymore. So, excellent point. You know, we missed those points. Is it the end of the world? No. Do I want to go back and fix that? Yes, because I have a little bit of OCD and neuroses. So we'll proceed for the time being, and we have the same line going through our 80 elevation. Okay. So
If you needed, jump
Yeah.
in there so I can talk. If you needed more resolution, is it okay to go ahead and do diagonals as well? Like between the 69.6 and the 81.2 and find.
yeah,
Okay.
yeah. If you absolutely want to, yes, totally. There are computer programs that do this for us now. So very rarely do we end up doing this by hand. But if you remember back to third grade, was it third grade or fifth grade? When did we do long division? And you had to go through and you had to do it by hand, and you had to draw out the little symbol, and you had to carry the one and then carry it down, right? And you had the remainder and all of that fun stuff. And you kept doing this by hand, and you're like, why the hell am I doing this by hand? Can I use a calculator? Well, yeah, but you had to understand why we're doing it. What's the process? How do I know if I'm getting the right answer, if I'm close? Sorry, I have dogs that are about to have conniptions over these treats. Here, you can have that one. Oh, sorry. Hang on, sorry. Worse than children fighting over toys. So yes, you can get very, very detailed. You can get very, very precise. What we're looking for on these kinds of problems for the purposes of this class are eyeballing it, sketching it in, figuring out what shape do we have? What are we looking for, right? Is it a hill? Is it a cliff? Is it a pond? So the quiz last week kind of stumped some people, because when you looked at that terrace, first of all, the word terrace to me means it's above the surrounding grade. But if you looked at the elevations, it was actually a sunken floor, right? It was a flat bottomed depression. So those are the kinds of things we want to look for. We want to be able to catch quickly and easily. We know we've got something going here. The big gap here tells me that this is relatively flat, right? You have to go a long way before you get that change in elevation. You get to that next elevation point. So it's a nice gradual slope. Whereas the closer we get here and here, we're getting a little steeper, right? You don't go as far and you still just dropped 5 feet.
Can I
So-
ask something?
Yes, please.
It doesn't look flat to me because it's 66 on the right of that empty space and 69 on the left. It looks to me like a little hill in the middle, to be honest, or something. Because there's some supposed to be lines, but I don't just know where they would go because I don't know.
Well, let's just take this straight line right here. All right, so we'll take this line. We're saying that this is 65 feet, right? And we're saying that this black X here is 70 feet. Now we do want to look at what's the spacing in between, right? So the spacing in between these 2 points, anybody remember what it was?
think I got it. Sorry, never mind. We are doing the 5-foot lines, not the 1-foot lines. That's why.
Mhm.
Yeah, sorry.
Yeah,
I got
no,
everybody
that's
confused and myself as well.
excellent
Sorry.
question. Excellent question. You're looking at that going, something's, how do I interpret this? And that's the whole point behind this exercise is what am I looking at? What is this telling me? How do I interpret the readings here? So what we do have is, you know, there's 50 feet here. So let's say that's about 10 feet from the blue X to the point where it's 66.2. And we know we've got another 50 feet to get to here at 69.6. Say we have another 10 feet to get to our 70 point mark. So what was that? 50 plus 10 plus 10 gives us 70 feet horizontal. What's my vertical change in elevation between those two X's? Anybody? I thought you were waving for a second.
Between the blue
Thank
and
you,
black
Kenny.
is
Yes.
5 feet. Sorry.
It's 5 feet. So you're going 70 feet distance to drop 5 feet. May not seem like much, may seem like a whole lot. All we have is this square that we're looking at. We don't have the whole countryside that we're analyzing. We just have this one little square that's 200 feet by 150 feet. Not even a football field, right? But we're saying that in that span, we're dropping 5 feet. Anybody out of curiosity do the math yet? What's our slope? Change in vertical over the change in horizontal is our slope. So if we divide our vertical component, 5 feet, by 70 feet horizontal component, convert it to a percentage. Yep. Elon posted it. 7.1% slope. So all along we've been giving you the slope and saying, go do the math. Now we're backtracking and figuring out, all right, well, is a 7% grade, is that a lot? Is that a little? Roadways, the crown in the middle, you know, when you go over some intersections, it kind of does that. That's usually about 2%. Sidewalks are graded at and built at about 2% slope across the sidewalk so that they drain. So that's 2%. 7% gets a little steeper. But even steeper still is here where we're jumping 5 feet in the distance of about 25 feet. That's a much steeper slope, even though I missed some points. So any questions on contours? Does that help anybody with the homework assignment? Make a little more sense? Okay. I liked this one because it had that little S curve in it. And that will, those kinds of things will throw you. Like, whoa, wait a second. What's really happening here? So reading and understanding topo maps, interpreting them is more of a challenge than creating them. Figuring out what it's telling you. Any questions on topography? Okay. See, oh, fun, earthwork and, oh, whoops, I missed something here. Earthwork and volumes. I mentioned it before, I'll say it again. We're going to talk about it a lot more. Keep track of your units, right? Mason, this kind of circles back to, okay, you made that assumption. You told me you went from square inches to inches. And I'm like, whoa, wait a second, how? That's what I'm seeing a lot on the homework is the units of measure were, I don't want to say we're sloppy about it. We're cavalier about putting the units of measure when we're doing the math. But now when we're getting to horizontal and vertical curves especially where we are dealing with a percent slope per station, those are weird ass units of measurements, right? So that sounds weird. What's even harder is the imperial units of measure, inches to feet to yards, just on the linear side, right? Then converting squares, converting area measurements, converting cubic measurements. How do you get from one to the other to the other? So keeping track of those factors really will help make sense out of the homework problems, out of the assignments. That happened a bunch. So I don't remember which homework it was, but there was a problem. It was a volume calculation for earthwork. And they missed the length between them. Took the areas, took the average, converted it from square feet, divided by 27 to get cubic feet. No, we ended up with the number of square feet per cubic foot. That's not really what we're looking for, right? We knew how many linear feet were in between those two end areas. So that's the kind of stuff to watch out for. And carrying along units of measure sometimes can help. Or do the problem with just units of measure. Make sure it works out. So we derived a bunch of formulas for horizontal and vertical curves. And especially on homework, I think it was one of the last questions on homework 11. Solving for all those variables in terms of other variables, putting them back into the main equation. You had random stuff canceling out here and there and fractions of a variable, and it was confusing. And it took me 4 or 5 tries to get the math to work out. And I had the answer key in front of me and I was still struggling with it. So going through and just making sure that everything cancels the way it's supposed to. Do you end up with the right numbers where you're supposed to? The units of measure especially. Watch out for slopes. When you are dealing with a slope, remember, if it's not expressed in a percentage, and this is where got to keep track of it, right? We just calculated, Elon proved that we've got, for every 7.1 feet we go vertical, there's a 100-foot horizontal component for that. And that's vertical to horizontal. But that's only when we're dealing with a percent slope. When we're dealing with a ratio, it's horizontal to vertical. Unless it is specified, rise over run. Rise over run, percent slope, those are the same thing. It's vertical to horizontal. Ratio expressions are horizontal to vertical. I hope I just said that correctly because that was a lot of horizontals and a lot of verticals. Okay. There it is. So here's my question. Who's up next? John. Which one would be a steeper slope? 1 to 5 or 5 to 1?
1 to 5.
Which one is the 1 to 5?
The taller one.
Absolutely. Okay. Everybody good there? So that's our 5 to 1. Our horizontal is 5 times longer than our vertical. Here, our horizontal is 1/5 of our vertical. And those are to scale, by the way. That is a 5-inch line and a 1-inch line. I'm getting way better with this graphics crap. Stuff, excuse me. So I'm pointing those out because it's the stuff that everybody is getting tripped up on. And I don't want to see errors or mistakes because of stuff like this, right? So that's why I'm going over it and over it again. Hopefully we'll drive it in so you don't have to worry about that part of it. You can think about the rest of the problems that we're looking at. Okay. Cross sections. So we didn't talk a whole lot about this in class. It was presented more in the textbook, but the way this is presented, I got to admit, it's not something I'm used to seeing in this way. Usually it's not labeled with the cut and fill. You might see that distance here in the middle called out. Most of the time we would use computer programs to calculate that end area, that cross section. But here, if we just have a couple of them, we've got our points, we can go out and we can stake it. We can go out, create and draw this cross section and look at it. This is basically, instead of a traverse that is horizontally dimensioned, this is a traverse that is vertically dimensioned. Okay, so when we're doing things like the double area method and you have your cut or fill as it relates to the coordinate, that's what I was looking for. The coordinate relative to this center line, you got to remember you have to close the traverse on that. You've got to come all the way back to the beginning. So if I were doing the double area method, my first one would be 8 over 31, 6 over 0, 5 over 25. Who's next? Neo's not here. Am I missing somebody? And Neo, you are here. You were hiding on my other screen. No, not an, oh, Mason, yes. Sorry, that didn't come in quite on time. This would be a negative 31. So since I was already calling on a Neo, Mason, I'm going to circle back to you. Why is it a negative 31?
Because it's left of the center line.
Bingo, yes. Okay, so thinking of it as a coordinate system, our center line and the bottom of our excavation, that's our 0, 0 point. Everything is then measured off of that. To the left is going to be negative, to the right is going to be positive. Cuts we consider positive, fills we consider negatives. So we keep in mind whether we're dealing with a cut or a fill. The double area method, you've got to come back around and close that traverse. Okay. So I've got, I think, 3 questions on this one. Anio, you're up. What are my side slopes?
The ratio is 2 to 1 on the right side and the left side.
Absolutely, yes. So it doesn't matter which direction it's going, it's still a 2 to 1 slope. dimension doesn't matter, or direction doesn't matter a whole hell of a lot there. Okay. Yes, 2 to 1 because it's over 2 horizontally for every 1 increment we go up vertically. All right. Atzine. Hope I'm not butchering names. I'm really sorry. What is my point of deepest cut?
Point of deepest cut, wouldn't it be 0, -6?
What's that?
0, -6. Like
Well,
right
this is my 0, 0 point.
Oh, that's 0, 0 point.
So it would be
It would be
0, -15. Okay. Yes, that point right there. Okay. How wide is my road base? This brings us back to Viri.
Is it the 8 feet? No. 6 feet?
I can't do a straight line with my mouse. I'm trying. What we're looking for is how wide is the base section? So how far left and how far right do we go off of that center line? Everything's going to get measured off that center line. Yeah, go ahead.
Is it just 30 then?
Yep.
Or 15? Yeah.
30 feet. That's it. Any questions on reading the cross sections? Same thing as the topos. What is it telling us? What story are we learning from that picture? A picture's worth 1,000 words. Now we know why, because there's a lot of stuff going on there. I don't know if I could use 1,000 words for it, but you know, there's still a lot going on, right? Any questions on the cross sections?
Yeah, so that the point of deepest cut, would that be like 0 over 15? Like how there are other
Over -15.
over -15. That's how you would write it.
Yep.
Cool.
Yeah. So the nice thing is by setting that coordinate system at our center line and the base of our cut at 0, 0, right? The really nice thing is that a lot of those cross multipliers, excuse me, drop out. All that multiplied by 0 goes away. So it's kind of a nice thing there. Makes the math a little bit cleaner. Horizontal curves, more fun stuff. I know everybody absolutely loved this the other day. Were there any specific questions on this? Everybody seemed to do really well on the homework. So if there was anything that you guys wanted to go over, any of the problems that you wanted me to walk through the solution on, more than happy to do that. But the horizontal curves, it looked like everybody was pretty comfortable with, fairly. Okay. Who was I talking to? Sorry, I don't quite remember. Talking about the interior angles and what we do when we're breaking it up into those segments, right? Whether we're doing the arc method or the chord method. If we're looking at the arc method, it means the arc of that curve is 100 feet long. If we're looking at the chord method, that horizontal line is 100 feet long. So if you ever get a chord using the chord method, using the arc method, either way, if you ever get a chord greater than 100, you know you've got a problem. So that's one quick little gut check, even off by a little bit. What that tells you is if you end up with something like a chord using the ARC method, a chord length of 100.01. That tells me it's rounding. We just need to carry out the numbers a little bit further. And it happens really a lot when you have things like 3 degrees, 20 minutes, and you've got a repeater in the decimal, right? That'll throw things off a little bit. Just go back and carry it out a little bit further. And those are the repeating ones. Those are the ones that you can just fill in the blanks, right? Pretty quick and easy. So the concept here, and I was feeling really good about this analogy the other day. When we do problems like this and with the homework, breaking that whole section, right, that whole curve into smaller sections. Really, we're dividing up a pie, right? Day after Thanksgiving, there's a little bit of pie left. Someone went at it with a spoon in the middle of the night, and so one of those edges is kind of raggedy. But you've got siblings and you have to share, and you want to make sure it has to be equal portions for everybody, right? You know, Jessica's not allowed to get any more, otherwise Alexander's going to throw a tantrum. So that's what we're looking for on those. What we have to do is we've got to break that into very, very equal segments. And we've just chosen for horizontal roadway curves, we choose that unit of measure of 100, one station long. Makes the math nice and easy for us on that. Otherwise, if it were actually pie, you could get out a little sewing tape, run it around the corner of the pie, mark it where every inch was, inch and a half, whatever is going to make that nice and easy for you. And that little jagged edge that somebody ate at in the middle of the night, you're going to cut that off. So we're going to have that little wedge to start it off, because we want to start with a nice clean edge on a nice whole station when we're talking roadway curves. Get to the other end. Well, that's for mom. Mom's going to want a little sliver too, you know, so if you save her some, you get on her good side a little bit. Give you some brownie points for when you really screw up. So the difference between the two, arc basis, chord basis, what you want to watch out for is the arc basis. We are assuming the arc itself is 100 feet. Chord basis, we're saying that the chord is 100 feet. So that's why we have 4 different formulas here. 2 to find the radius, 2 to find the length, because it's going to vary. Your method of approach is going to be different. So here, if we're trying to find the chord length, we're dealing with nice triangles. If we're trying to find the arc length, now we're dealing with radians, circumferences, 2 pi r, okay? So that's the difference between the two, is what shape do we have to do the math with? Did anybody have any questions on these problems? Again, everybody seemed to be doing pretty well on it. The homeworks that I did look at already. So if you want me to go through any of the problems, any of the homework problems, we can absolutely do that. Just let me know which one you want to talk about. But I will keep going here. Vertical curves. So vertical curves kind of, I screwed up. Let me just start out with that. I loved that some of the people that I talked to over the course of the week pointed out some mistakes that I had, some errors that I had, right? I just went along, I did the math, made mistakes. If you show your work, you can go back and figure out where those mistakes occurred and then catch up and fix it. So I did upload the revisions to question 1 and question 2. I have not replaced them in the overall solutions just yet. Eventually I'll make that one complete document, but right now it's 2 different documents. Questions 1 and 2, you'll see that I made revisions to them. We have our little race car. So we're coming back to this example problem that we went over a couple weeks or last week. Remember, we're dealing with a parabolic curve. So we have a square of the distance. It's the slope times the distance to figure out how fast are we changing, how fast we're changing, right? Just like with units of measure that I mentioned earlier, watching out for how the slope is presented, whether it's horizontal to vertical as a ratio, whether it's a percentage, which then gives you vertical to horizontal. Still here on vertical curves, watch your units of measure. This is where they get weird. Percent slope, stationing. So it might be reported in stations. It might be reported in hundreds of feet, and it might be reported by numbers of stations. So this example here, the number of stations is 6. L is the number of stations that we're looking at. So we would use 6 for L. And watch the signs. Signs for your slopes and the value for R. Those do come into play. You can't just drop them. You can't just get rid of them. Can't just ignore them. I've tried. You've seen what happens. Mistakes get made. Always start from the beginning of your vertical curve. So your PVC, point of vertical curve, your BVC, beginning of vertical curve. That's the hard part with this particular subject is it, which nomenclature are we using? 3 formulas on this page. Those are going to be the keys that you're going to want to remember. A lot fewer equations than we have when we're dealing with horizontal curves. There's less information that we need, right? So all of this is based on the distance X. How far are we from that beginning point, from that 0 point? High and low points, again, don't forget the sign, and it's measured from that beginning of vertical curve. So we've got a little bit more example. Anybody got questions so far? Guys doing all right? How are we doing on time? 7 o'clock right now, 7:10. I've got just a little bit more to go through. You guys can hang on. Be sure and blow on the coffee cup. It helps. Hey, easy dogs. High and low points. The formula for figuring out where that high or low point exists. That's all it's telling us, is how far that point is from the beginning of our vertical curve. I made a mistake on question 1, and I went based off of my point of intersection instead of my beginning vertical curve. Oops. So that screwed up my numbers. Means I had the wrong high spot marked, had to go back and redo the math. As I noticed on some of your homeworks, that's a lot of really tedious math, right? There's no really easy way to run this through a calculator over and over and over again, right? So if you can get comfortable with Excel, if you can get comfortable with something that'll do that for you, that'll be great. So where would I begin to find the high point? Viri, I already called on you. Victoria, you're up. For a little dog, she sure is noisy. Victoria, you here? No?
Yes.
Oh, yes, there you are. Were you talking to the mute button?
No, I was just telling my cousin to be quiet because she was a little loud before I actually spoke.
So let me back up here. Where do we want to start? If we wanted to find, given this information here that we see on the screen, we wanted to find our high point, where would we start?
You would need to find the X or the, yeah, right?
Yes. But in order to find X, what are we missing?
The R?
Yes. Okay. So if we need to find R, let's see if my little animations work on this. So where do we start for R? We've got our formula. So what are our variables here? What's G2? Othello.
So G2 would be the back slope that we have, which would be 2.40%, it looks like. And then G1 would be the forward slope that we have, which is the 3.00%.
What does this say? Right there.
Watch the signs.
So what is G2 then?
G2 that would be the negative 2.40%. Oh, I didn't say negative, sorry. I spoke so fast I tripped over my own tongue. All right, yeah.
I have no idea what that's like.
Yeah.
Okay. So you
Thank you for
really have
catching
to
me,
watch
though.
the signs. This is where it comes in, right? That will make a big difference in what our value for R is, our rate of change of slope, of curvature. All right. And you gave us G2 or G1. You said that was 3%, but that's a positive. So what's our L? Let's go to Olga.
The L is the length of the horizontal part, which is between station 44 and 49, plus 70 on the right and plus 30 on the left.
So what's the overall?
1 second. 1, 2, 3, 4, 5. 500, 600 feet. Right?
Absolutely. So L is going to be 6 because we're looking at number of stations. All right. So we have our negative 2.4, subtracting our positive 3%, dividing by 6. So our rate of change per horizontal distance is negative 0.9%. So for every foot we go, it's not that we're dropping 0.9%, it's just that our curve slope is coming down. We're getting flatter and flatter, right? So that's what that is telling us. That negative number means we have a negative slope, but it's based on every increment we go to the right. Random hair tickling me. Okay. So what do we need to do next? We've got R, we've got G1. Victoria told us we need to calculate X. So our formula is negative G1 divided by R. Miles, what's our negative G1?
Negative G1 is negative 3%.
Divided by, what's our R?
Negative 0.9.
Absolutely. Okay. So keeping track of our units of measure. Given the unit of measure for each one of those variables, what unit of measure should we get for X? Mason.
Yeah. What we get for that?
For unit of measure. So G has a unit of measure of what?
Oh, it'd be negative 3.33.
Not
Oh,
talking about the
you're
math.
not asking that.
No. Not yet. That's next. What, carrying through the units of measure. If we take negative G1 divided by R,
Mm-hmm.
what unit of measure should
Oh,
we get?
you should get feet, right? No, percent per station, right?
That's the value, that's the unit of measure for R.
Oh, okay.
Dividing by a fraction, invert the fraction. Same thing with units of measure. Lucy, calm down. She really likes that stick.
I'm not
Alright.
sure for the unit of measure.
Is the
Okay.
final unit stations?
It is.
Oh, okay.
It is. And that's the thing with vertical curves, is you end up with these funky units of measure, but you got to make sure you're carrying them through, because if you did treat it as a number of feet, we're going to end up with the wrong answer. We need to look at it as a number of stations. So the unit of measure really does become pretty critical. We've got to keep track of what it is we're adding and subtracting. Okay. Yes, 3.33 stations from the beginning of our vertical curve. She's out of breath from chewing on that stick so hard. She's 12 pounds. It was as big as she was. All right. So now we know how far that point is. We know where it's located. What station is that going to be? Kenny, where are you now? You can shout.
47.
Close. Tell me how you'd come up with the number and we'll figure out what that number needs to be.
Well, if it's 3.3 stations from the beginning, that looks like about a third of the station between 43, 70, and 44. And then I just go 3 more stations, which would be 45, 46, and 47.
Okay. So the 3 stations, we add, we can say we have, hang on, why am I blanking on that? So if we convert that number of stations to a station representation, 3 plus 33, we can use that to add it to the original station of 43 plus 70. So
I'd be about 3 feet
40.
off.
Well, that, you know, if we're digging for gold, 3 feet can mean a lot, right? Okay. If we have to avoid that historical monument at the top of the hill, otherwise we're paying billions of dollars in damages. I know, I harp on that and then I make sloppy mistakes myself. There's a reason I went into construction, not design. So yes, that's what we're looking for, is we're adding those 2 together. You can also drop the plus signs, right? You can say it's 3.33 stations plus 43.7 stations. You can convert that to feet. Just make sure you're consistent with your units of measure. When you're doing the calculations, make sure you're presenting them the same way for that calculation. So here we end up with a calculation for the number of stations as a decimal. Here we're using station nomenclature. We could also convert that straight to feet. 4,370 plus 333 feet, and do the math that way. How you do the math isn't as important as consistency in what you're adding together, right? What variables you're using. So our elevation at that point John, how would we get started there?
We'd use the parabola equation.
Exactly. Okay. I had to convert to a decimal because I was running out of superscript and subscript. So 0.5, it's 1/2 r x squared plus g1x plus the elevation at the beginning of our vertical curve. Last week, we already calculated what all that was. We figured all those points out. When you plug into this equation, don't forget, if your r is a negative value, you need to carry that negative along. If G1 is a negative value because you have a sag, you have to carry that sign along, okay? Plug those values in. Come up with 849.48 feet in elevation. Okay, you ready for the fun stuff? Yay. All right, so that's what we're looking for there. What's the station and what's the elevation? Where's our high point? Okay. Did that help clear up anything on vertical curves? Still clear as mud? Maybe the window's just a little smeary? I mean, we're not talking crystal ball. Don't expect it to be. Okay. Yeah, to which one, Mason? Okay, anybody have any questions? Anything you want me to go over? Anything you want to repeat?
So I think I had a question for horizontal curves.
Okay.
And I think it was, there's a certain question in the homework, I don't remember, but was over, it's over getting the BVC through the slope. At least that's how I did it, or the beginning point, and just because sometimes I have a hard time finding the starting point. That took me forever, but just what's the process for that? Because I know I did my own process for it. No, it wasn't horizontal curves, it was vertical curves, and just finding the BVC and starting from there. Yeah.
I didn't like that one. And unfortunately, it is a very valid question. Very possible when we're talking design and engineering. But yeah, it's a messy one. It's tough. Let's see. No. Yes. Everybody remember 23, chapter 23, problem 21?
Yeah, and so I did a totally different way. I did how the textbook did it. I wanted to see if you had done it the way with substituting for else, and I tried that. And I mean, I got as far as, how far did I get? Well, I had everything set up. Maybe I didn't get the PVI right. That might have been one where I was tripping up over myself, and then everything else didn't work out because of that. But.
So that one, that little concept right there, that was kind of tricky. So that one we know because we were given the two stations. We know what the PVI is, it's at station 67. We know what the station is we're trying to make sure we pass through at that elevation, it's 68. So we know that we can plug it into that formula and use that to solve for other variables, right? So that's how we're able to say that the PVI is L over 2. We're saying it's equal tangents. So by having it L over 2 plus 1, that's the X at station 68. Because we don't know what the BVC is just yet. We're trying to solve for all of those factors. Does that make sense?
Yeah, for the most part, it does. And then the EBVC is really interesting when I take a look, where you have the M and L over 2. How did the M come into play with that?
You'll love this one. Okay, this goes way back. Y equals mx plus b.
That's what I was thinking. Okay, I just want to make sure that my train of thought was correct with that. So
Yeah, that was, do not expect something like that on the test. No, I'm not doing shit like that to you guys. No. Okay. I don't know if you can see, but there was a lot of stuff that got erased on that piece of paper. And there's a reason I had to go to a next page. There's a lot of stuff that got erased on this page as well. This one took us way back into mathematics, right? That was more of a math assignment than it was surveying. The overall concept, hey, I have this point at this location, I have to hit that. How do I, and this is where the term comes in, reverse engineer that? How do I back into that being my answer? Well, the secret is math, right? Anybody else have questions? Anything else you want me to go through? Do you need a break? It's 7:30. Crickets? Okay. So here's my question to you guys. On a scale of Baby Yoda, because it's adorable, how are you guys feeling about being ready for this test? Honestly.
Is that scale going up or going down?
I'm seeing a lot of 7s and I don't understand. Honestly, I don't even know what that reaction's supposed to be.
Well, it's kind of like.
that's why. I think it's the whole one combined.
I was kind of thinking 6s, but or 3. 1 could fit too. 7.5. All right. Okay, I'm gonna try. We are gonna have a change of plans. Exam 3, and I know I pushed and pushed and pushed so that we would have exam 3, which gave us next week to study for the final, to review for the final exam. Everybody I've spoken to, Joanne included, said you did vertical curves and horizontal curves in one session. We crammed a lot of information into that one class. Those are the 2 biggest sections of the semester. So here's what I'm going to propose instead. And since, you know, this isn't a democracy, it's a dictatorship, this is what we're going to do. Instead of exam 3 would be worth 100 points. Right? And if anybody is feeling kind of iffy about it, you think maybe you're going to get a 50, a 60, a 70. Why don't we risk 20 points and do the 2 quizzes for those sections instead? Remember, your lowest quiz scores, 2 of them get tossed out. So really, this is kind of a much more fair way to go about it, I think. Gives you a little practice, gives you that jumping off point. It's 2 quizzes in one evening. Each one will be worth 10 points separately. They're going to be graded on their own, even though I've set it up as 2 questions in one quiz. There we go. So the details. Here's where we're at with that. So tonight, 2 quizzes, 10 points each. Marcine has agreed to host study sessions to get ready for the exam. Any questions you have about anything coming into the final exam, okay? There are some conditions. This is extra credit. Attendance is not mandatory, but it is extra credit. My authoritarian comment on that is I have asked, Marcine to put together a sign-up sheet. If you sign up, you must attend. If you do not sign up, no harm, no foul. If nobody signs up, she's not hosting the session. Okay, so don't hold back thinking somebody else is going to be there and then you can just kind of piggyback on that. You got to, if you're going to gamble, you better put your own money on the table. So you will receive five exam points. So we'll add that to whatever your lowest exam grade was to get that bumped up a little bit. Okay, so you're going to get points for the exam by attending a study session. If you sign up, you are committed. If you are a no-show, you will lose 5 points. Marcine has her own finals to study for. She doesn't need you screwing around. Okay. The 7th, Marcine, I'll come back to you and let you tell everybody about your sign up. The 7th, so next Monday. This is our second to last session. We will do our exam. First thing, right off the bat, 100 points, topography, earthwork, and curves. All 3 things that we've covered tonight, all 3 things that you're gonna hit on the, well, 2 things that you're gonna hit on the quizzes. You've got Marcine's availability. You've got my availability. Some of you are making appointments for office hours. I love it. That's great. Because honestly, I sit there every Wednesday for 2 hours and do my day job. Nobody shows up. If that time doesn't work for you guys, let me know. We'll find a time that does. I know it's kind of late in the semester for doing that, but one-on-one works just as well. Then we will review for the final exam after exam 3. It is going to be cumulative. Study guides will be posted. Office hours, make an appointment. We'll go over whatever questions you have. We have review guides. We've got study guides that will be available. So if you want to go through any one of those questions, got questions on a problem, let us know. We're here to help, okay? Marcine, any comments?
Yeah, I'm gonna post a on the discussion board, so you can reply to the discussion if you want to sign up. And right now I'm thinking of doing the week before finals, Wednesday and Thursday from 4 to 6, but if you have any suggestions, you can post them in the discussion as well. I'm open to change that if most of you guys aren't able to make that.
Okay, so there's 2 of us saying, whatever you need, we are here to help. Okay. Any questions? Any concerns? I'm going for teacher of the year here. I'm trying.
Yeah, so I just have a quick question, and I know it's on the syllabus and everything. I'm a little unsure. What's the last focus for this class, the last topic that we'll be kind of focusing on? And I feel like we might be focusing on that next week.
That would be registration, professional registration, the requirements to become a professional engineer, to get your stamp, the process to take the fundamentals of engineering exam, that sort of thing. If anything is going to get dropped in order to review and make sure we're all ready for the final exam, that is the thing to get dropped. Not to discredit the importance of it, but there are so many other classes that are going to cover that. Right. There is so much more to our education to come before we get to that point. I'd rather focus on surveying, the topics applied to it, and get you guys to nail the final,
Well,
really.
and thank you. And I've definitely heard from Joanne that she does cover it quite a bit, or just like sneaks it in there as well in a few of her classes.
Yeah.
So.
And trust me, I mean, from what I remember going through, there's people around you, well, usually on campus that are talking about it. There's posters, there's flyers, there's all kinds of ways of communicating what the next steps are. So let's just focus on surveying. We don't need to add anything else to what's going on, okay? All right. So let me go ahead and say it is 7:37 right now. I was going to give you guys an hour to do the quizzes. Is that fair? Good there? Okay. John? Okay. I cracked a smile. Yay. All right. So let's take 10 minutes, 12 minutes, come back at 7:50, and we'll take the last hour of class, do the quizzes. I'll get homeworks, quizzes, everything back to you guys by the end of the day tomorrow. Somebody hold me to that. And we'll go from there. So 7:50, see you guys back here. All right, my computer says it's 7:50. Fitbit says 7:50. I know, I just wear it as a watch. Good luck on the quiz. If you have any questions, don't hesitate to ask. If you need clarification on a question, let me know. Somebody else might have the same question. Good luck.
I don't know if it's just me, but question 1, I don't seem to be able to make a choice. I just see the questions, but I can't.
Oh, sorry. Oh, sorry. Yeah.
I was muted. It's a file upload question. So basically take all those questions, do them on your own, and then upload a screenshot of your solutions.
Okay.
Okay.
So, Sarah, I'm a little confused by just a horizontal curves question 3 because you ask about t, but as you know, something goes on with that. Is PC supposed to be pi in this case then?
PC is point of curvature.
Right.
Hang on, let me check. Keep working. Let me double check that and get back to you.
So Sarah, I already turned in my quiz, but I had to just quick question. I had an aha moment for number 4, and I was wondering, did you want an explanation or an equation for that? Oh, you're muted.
There is just about 20 minutes remaining. 15 minutes remaining. Just 10 minutes remaining. Five minutes. Kenny?
I'm trying.
Okay, I don't know if it'll let you. That's what's worrying me. Oh. Okay, I think it went.
Really? Huh. I'll email you a copy just in case.
Okay. Mm. Oh. Well, I can, let's see. Do you just need some extra time?
Well, extra time would be nice. I actually was working on one problem and then it said time up, submit. And I tried to submit and then it blinked off. So I think it might have just got like an empty file.
Okay.
I was saving it as a PDF. So I've got a PDF to send you.
Okay.
If that would, yeah.
Yeah, that's sufficient.
Okay. But I had so many windows open that it was like click, click, click. So
Waiting for it
I
to
was like,
catch up.
well, yeah, and I was closing off the paint program I was using to draw in, and then it was like it hung up for a second, and then
That's all it
I didn't
takes.
see the clock behind. I was like, I've got a minute, and that was like 5, 4, 3, 2. I was like, what? So let me.
All right, I'm gonna stop recording here.